Hello everyone. This video covers the lecture notes for week number 4. This is one of the shortest videos. We're only going to talk about maximum and minimum, which sometimes is just called local extrema. So before we actually go to the definitions, let me give you a very simple example, kind of like a side note. Alright, so we have a function that looks like this. This point right here, which let's say that the value for x is a, well, clearly that will be f of a. This is called a local minimum, and this one, which is the biggest value, it will be called the local maximum. And you can actually have more than one local minimum and more than one local maximum. For example, you can have something that looks like this. And these will be local minimums, and this will be a local maximum. Okay, so that's pretty much what it means. Now here is the formal definition. So a function f, which could be this, has a local maximum at x equals to a, or whatever this value is, if f of x is greater than or equal to f of x for all x in an interval containing a. All that means is, you can see from here, it's obvious that this value is bigger than this one or this one, so that's why this is the maximum. The opposite definition will be for the local minimum. This value is clearly less than this one or this one. Same thing here. If this is a minimum, this is less than this and this. If this is minimum, this is less than this and this. So this is kind of obvious from the picture. And obviously, this is bigger than this one or this one. That's why it will be the local maximum. Notice that the arrows, this is going to infinity. They actually don't apply for the local minimum, local maximum. We'll talk about these arrows later. For now, all we care is about either local maximum or local minimum. One thing that is important to notice is the following. This side note here. If f is an endpoint for the domain, then we do not consider x a to be a local maximum or minimum. And an example of that will be something like this. Let's say you have a function that looks like this. Okay. And let's say that we only go from here to here. You can see that clearly this is a minimum, this is a minimum, and this is a maximum. This is actually higher than this one, but since this is an endpoint, this is not considered a maximum. So not consider a local maximum. Okay, so only if it happens inside the interval, not at the endpoints. All right, let's look to a specific example. So this graph and all of this is part of the graph is called h of x. So that will be the function h of x, and this is also part of h of x. So this is a piecewise function. The first part is asking you to find the domain, and since this function is divided into two pieces, you could say that the first piece, which goes from here to here, has a domain of -2 to 6. So for the first part, you can say the domain is from -2 to 6, not including the 6. And the second part, it will include the 6, and it will go from 6 to 9. Or you could write in terms of x, you can say -2 less than equals to x less than 6, or 6 less than equals to x less than equals to 9. So that's the domain. Now the range, remember, are the y values or the output. The lowest that the graph goes is to this value, which is -5, and the highest it goes is to this one, which is 6. So therefore the range will go from -5 to 6. Or you can say -5 less than equals to y less than equals to 6. Alright, now part C is asking find the interval or intervals in which h is increasing. Increasing just means it has a positive slope. So here, from this graph, from here to here is increasing. It's also increasing from here all the way until you get to 6. And finally it's increasing in this part. So therefore we will write that in interval notation. This will go from 1 to 2, including 1 and including 2, or from 3 to 6, not including the 6, and finally from 8 to 9, including both the 8 and the 9. The next part is asking what is this decreasing. Decreasing means it goes down or has a negative slope, so clearly this is decreasing, the part in red. This is also decreasing, and this part is also decreasing. So if we write an interval notation, this will be from -2 to 1, or from 2 to 3, or from 6 to 8. Now, one thing to point out that is very, very, very important is the following. So notice this part, this is decreasing until it gets to 1. But once it gets to 1, this actually becomes 0, which means it's flat. And then after that, it starts increasing. So therefore, in reality, the endpoints, when this happens, you're supposed to use parentheses instead of brackets. So therefore, this should be from -2, 1, and this technically should have been a parenthesis, and therefore this should be a parenthesis 2. But if you leave it as brackets, it will be okay. But the correct way, when this happens, when it changes from decreasing to increasing at that specific point, the correct thing is to use a parenthesis. But if you use a bracket, it's fine. Right, the last part is asking to identify the actual minimums and the actual maximums. Here, you can see that we have 2 local minimums, one here, and then we have another one here. So it's technically 3 local minimums, and we only have 1 maximum right here. So therefore, h has a local minimum value of -5, and this is obtained when x is equals to 1, which is this value right here. And then you have another -5, and this is obtained when x is equals to 3, and the last one is this one, so the value for that one is 2, and that happens when x is equals to 8. And then for the maximum, you have a maximum right here, which is -4, and that happens when x is equals to 2. And then it looks like you may have another maximum here, or here, or here, but remember you cannot use the endpoints, so therefore you don't have any more maximums. That's it. Right, let's do one more example. Let's say you have the following graph, and it is steps here and steps there. So if I ask you what is the local minimum, you can see that you have 2 local minimums, one here and the other one there. And the first one happens when x is equals to -1. So the local minimum will be -4 when x equals to -1. And the other one will be 0 when x is equals to 3. Or you can write this one like f of -1 equals to -4 is a local minimum, or f of 3 equals to 0 is also a local minimum. In here you have a local maximum, and that happens kind of here where x equals to 1.5, and you can see this is like 0.7. So the maximum will be 0.7 when x is equals to 1.5, or f of 1.5 gives you 0.7, and this will be the local maximum. Now if I ask you what is this increasing, this is increasing from -1 to 1.5, decreasing from 1.5 to 3, and then increasing from 3 to 4, and decreasing again from -2 to -1. Okay, so therefore if I say the intervals of increasing, it will go from this part. So increasing will be this, then this. So it will go from -1 to 1.5, and notice how now I'm using the parentheses instead of the brackets. So this is technically the correct way to do it, but if you use brackets, it should be okay for now. Or from 3 to 4, and decreasing, it will go from -2 to -1, and 1.5 to 3, and that's it. Okay, well, let's do the decreasing too. So interval, or intervals of, should be of decreasing, you will go from -2 to -1, or 1.5 to 3, which will be this part. this, and this. And that's it. So I told you this video will be the shortest one. I think this is actually the shortest one of the whole semester. Alright, so that's it.